We will continue to solve quadratic equations including trigonometric ratios. We will work on this example. However, pay attention. In some equations, you may need to use the identity sine squared a plus cosine squared a equals to 1 before they are in a form to be solved by factorizing or use of the formula. In this example, we need to find the value of x in the interval where x is between minus pi and pi, satisfying the equation 2 cosine squared x plus 9 sine x equals 3 sine squared x. Here we have cosine and sine as quadratic equations. We need to use the identity in order to change it all to be in one trigonometric ratio. So all of it in terms of cosine or sine, then we factorize. Let's start. We have the equation. We have cosine squared, sine, and sine squared. So it is easier to change cosine squared to a formula that contains sine squared. First of all, we have this equation. We know sine squared x plus cosine squared x is equal to 1. That means cosine squared x is 1 minus sine squared x. So we will substitute this inside the equation. Therefore, 2 multiplied by 1 minus sine squared x. And we continue writing the equation as it is above. Equals 3 sine squared x. Okay. Now we need to expand. 2 minus 2 sine squared x plus 9 sine x equals 3 sine squared x. We will make the equation equal to 0. Minus 2 sine squared x. We subtract minus 3 sine squared x on both sides, so minus 3 sine squared x plus 9 sine x plus 2 all equals to 0. We also organize the equation. We put the power 2 first, then the sign, then the constant equals to 0. Okay. Minus 2 sine squared x minus 3 sine squared x is minus 5 sine squared x. Plus 9 sine x plus 2 is equal to 0. Usually the coefficient of the power 2 is positive, so we are going to multiply the entire equation by minus 1. Plus 5 sine squared x minus 9 sine x minus 2 equals to 0. This is the quadratic equation that we already worked with previously. Now we need to factorize it, so let's represent it in the form of x. 5 capital X squared. Let sine x be capital X. Okay, now let's continue writing the equation. 5x squared minus 9x minus 2 all equals to 0. This is the same as ax squared plus bx plus c equals to 0. Remember that we multiply a by c. That means 5 times minus 2. The answer is minus 10. We need to find two factors for minus 10 such that if we multiply them together we get minus 10, and if we add them we get b, which is minus 9. The two values are minus 10 and plus 1. 5x squared minus 10x plus 1x minus 2 equals to 0. It changed from 3 terms to 4 terms. Now we group. 5x squared minus 10x plus 1x minus 2 equals to 0. We factorize. 5x is common. What remains is x minus 2 plus x minus 2 all equals to 0. The common is now x minus 2. Multiplied by what remains outside, so 5x plus 1 is equal to 0. In order to solve, we set each one to equal to 0, so x is plus 2, or x is minus 1 over 5. This is how we solve the first part of this equation. As a recap, we wrote the cosine in the form of sine, then we substituted inside the equation and organized it. Finally, we factorized and calculated the solutions. We will continue solving this in the next tutorial, where we will find angle x which satisfies this relation.